All right, welcome back. My name's Floyd. I'm Frank's cousin from up north, North Pole wise. Do know Santa. So if you got any questions, you can ask me after this tutorial. So Mr. Krolak tells me we're working on integration, and you've done integration, finding the area under a curve, between a curve and the x-axis. Yes? All righty. Well, today we're going to do the area between two curves. So let's take a look at that. We shrink this down, please? Yeah, thank you. Alrighty. So if you look up here, we got two functions. We got a function g and we've got a function f. And we want to find the area that is between the two functions. All right. So in order for us to do that, we've got to be able to find the determine which one is the upper function and which one is the lower function. So u sub y sub u upper, y sub l lower. So to find the area between these two functions, what we're going to do is subtract them, subtract their integrals. So basically, by taking the upper function and finding the integral, we're finding this entire area. And then if we take away the area that's beneath the lower curve in the x-axis from this area here, then we're going to be left with the area between the two curves. That's what we're going to be doing. So to find the area between two curves, you take the upper function, subtract the lower function, and that's your integral. All right. Now your a and your b values, okay, are going to be most of the time are going to be between where the two graphs intersect. All right, so let's take a look at an example here. It helps if you have Desmos open so that you can graph them and see where they touch, okay, where they intersect. So, okay, so if you look above me here, you can see that you got, I graphed the two functions. So f of x is the upper function in red, and g of x is the lower function here in blue. And then I subtracted them and I did where they intersected. So to get the intersection, I just found so Desmos is really handy for this. It saves you a lot of algebra. So my lower limit is 1, that x coordinate, and my upper limit was 4. So now that's the area that's between these two functions. So it's pretty easy using Desmos, huh? Alrighty. So let's take a look if we're going old school here, and we're finding the values. Okay. So to save some time, we know we used Desmos to do this part. So we got this is x equals 1, and this is x equals 4. If we were to do that by hand, we would take the two equations and set them equal to each other, and then solve this for x. All right, so I just get everything on one side. Let's see, subtract 2x from both sides, subtract 1 from both sides. That factors into x minus 4, x plus 1. No, it should be x minus 1. Let's see where they. Oh, that's a plus 4. Okay, so that tells you where the two intersection points are. So I got an intersection at 4 and an intersection at 1. All right, so we've sketched it. We found the two values where they intersect, and now we do the integral. So it goes from 1 to 4. Okay, and I'm going to do f of x, which is 2x plus 1. Let's do it like this. Minus g of x d of x. Okay. And we'll just do our integration then. Okay, so once I combine all these, all right, and then I can just break that up, take the integral of that, or I can break it up into 3 integrals if I wanted. I'll just leave it as is. So now I take the antiderivative of each one. Evaluate that from 1 to 4. And now it's just a matter of doing the arithmetic and not losing negatives anywhere. That's probably the biggest deal. Okay, so I'm going to write that out and be right back. Save a little bit of tape. All right, here's after all the work that we had to do. And I'm not going to go through all the arithmetic here, but we end up with 4.5. And that's our area, just like Desmos predicted, between those two curves. All righty. Find the total area. Now, this time you have a portion of the curve that is negative. Now, here's where you got to be careful. If we just plainly integrate, then we would end up with the net area. Okay, but we want to end up with the total area. All right, so one thing that we did the other day when we did this was we did when we integrated it, we took the absolute value. All righty, so let's set this guy up. All righty, so if we were doing this on Desmos, then we can see we want to find the area that's under this curve here, plus this area between 0 and 1 that is under the x-axis. So that area plus this area. Now, if we integrate, it'll give us the net area. This area here on the left between -3 and 0 would be a positive. This area here would be a negative, and it would subtract the two. So to get the integral of the total area, we want this part to be above the x-axis. Okay, so that's real simple to do. You just absolute value it. So you can do it, you can set up a new equation that absolute values it. And I can just call it g of x, and I just go ABS f of x. Okay, and that's the absolute value of that function, and we want to do it from -3 to 1. So now to integrate it, I go to my functions, miscellaneous, integral, and we were going from -3 to 1. So left to right, -3, 1, and g of x dx, and there's my integral. That's the total area. Okay, if I made this f of x, notice that's going to drop. F of x now has that little negative area. This is the net area. G of x is the total area. And that's what we're looking for here. Okay, all right, now doing it old school, what we would do for this is we would do two integrals. Okay, this would be our one integral, the area under that curve and above the x-axis. All right, so that would be, we said it was from -3 to 0. Now, if I didn't use Desmos, I'd have to solve this equation for x and get where the x-intercepts were. Okay. And I would do, if I was going to do that, let's just do it real quick in case you forgot. I could factor out an x. Okay, then I can factor this quadratic into x plus 3, x minus 1. And then what's going to make each one of these factors equal to 0. So 0, -3, and 1. Alrighty, so back over here to here. We would do the integral from -3 to 0. Okay, and then in this case, we would add the absolute value of the integral from 0 to 1. And that would give us our total area. Okay, so I'll do the arithmetic just so you can see it, and then I'll be right back. And then there's all your math. So this section over here in yellow, that was this side right here. And then we did the absolute value of this area, which was this. And then we added those two up. Make sure you appreciate Desmos, huh? Alrighty. All right, our last example here, I did a bunch of pre-writing on it just to kind of speed things up a bit. So let's see what we got going on here. So you're asked to find the total area of the portion under this curve here. All right, so I shaded that yellow. The area under the line x plus 2, that's our upper function, and above the blue parabola, which is our lower function. So if our rules on how we find the area between two curves applies, okay, we would take the upper function, subtract the lower function. So that's what I did here. And then once we simplify that, we get -x² plus 4. That's this function right down here. And then I did the integral of that function from -2 to 2. Now, where I got the -2 to 2 was I set these two functions equal to each other and solved it. All right, and I can see one x-intercept is -2, and the other one, the other x-coordinate is 2. So if this works, okay, we should end up, this over here should end up giving us 10.6 repeating, or 10 2/3. All right, so here's the integral of that. If we subtract those two functions, and then this is the math that goes along with that. That's where the 10 2/3 came from. All right. All right. Now let's see if that is true. All right, so to help you see it a little bit clearer, what I did was I did the integral from -2 to 2 of the upper function. That's this function in green. All right, and I just used Desmos to do that, and you can see that we got a integral. The area under that curve is just a triangle, and that's equal to 8. All right, so that was this section right here. Now, the area that is bounded by the x-axis and the parabola are these two little pieces right here. So using Desmos to get those areas, what I did was I drew that graph. Just a second here. Come on, mouse. There we go. Alrighty, here we go. All right. So there's that graph. And if I do the area from -2 to 1, that's this little negative portion there, that's 4.5. All right. So the area from 1, if I make this, let's say 1, and then to 2, okay, that's 1.83. Okay, that's the same as 11 over 6. That's this little portion. And the reason I did it like that, because if I do the integral like from -2 to 2, it gives me the net area. And I want the total area in this particular case that's under that curve. All right. So if I wanted to get that, I could just take this and do absolute value, and that gives me the total area there. Okay. All right. Now back to this then. So if we were to take these two drawings here and we wanted to get the area of that yellow part, well, I would take the area of the green plus this, not the negative of that, but actually the positive of that. That would be this. So this portion right here would be, if you think about it as 4.5, because we're talking about a total area. Now to get the area of this yellow part, that would be the area of this green section, which is 8. Take away the area, that little skinny area right there, which we found out was 11 over 6. And then if we add those or subtract those two, that's going to give us this section right here. So that would be 48 over 6 minus 11 over 6. So that gives us 37 over 6. That's this little portion. Now, if we add those two up, we should get our total area here. Okay, so if I did 4.5, and then I add 37 over 6, that's going to be, oops, that would be 27. Let's see, 6 times 3, so 27 plus 37 over 6, which is 464 over 6. And if I reduce that, I get 32 over 3, which is 10 2/3. Okay. So that's kind of a long about way of getting to verify that this is the same as just subtracting the two functions. And if we did it this way here, here's where I actually just subtracted the two. So this was the area 8. This area was made up of -9/2 plus 11 over 6. All right, but you're subtracting it, so that's going to end up turning to a positive, you'll see, and then we end up subtracting that little rectangle, which is exactly what we did over here. So it works out that if you take the upper function, subtract the lower function, and then integrate, you're going to get the correct area. All right, folks, that's it. I'll see you next time. And from Frank, he's a brown bear. I'm Floyd. I'm from up north, the white bear. And thanks for Mr. Krolik letting us help you guys. And see you next time.